Alright students, so this question is also on angular momentum. Now this category of question is a bit different than what we have been doing. Okay, what is different about it? Let's read the question. So the question is on the screen. Read it very carefully. You have a disk which is rolling. Okay, the axis is given here. Okay, origin. I will just show you the complete diagram, and it is rolling. It is given, right? So you have to find the total angular momentum of this disk when the axis is origin. Okay, read the question, take 5 seconds, read the question, look at the choices. The mass of the disk is given to you. So the mass of the disk is available, right? So this is your mass, the radius of the disk is available to you, right? This information is given, and what is also given is the fact that the disk is rolling. Okay, so I'll just reduce the size of the question now, and you could probably, okay, so this is it. Okay, all right. So I will just position it somewhere where we can, read it easily. Okay, so I can write something. So I have space. Okay, all right. Now let's see the approach we have to take. Now this situation, when the axis is not on the rigid body but outside the rigid body, right, is a different question. We call this angular momentum of a body when the axis is outside the body. Okay, how do we solve it? What we do is we find the angular momentum of the body about its own axis. Okay, so assume this is moving. If you have to find its angular momentum, then we know the angular momentum is equal to L is equal to I omega is equal to mr square by 2 into omega, which is its angular velocity. Okay. Now we know when the body is rolling, what happens? The center of the mass, the velocity is given by r omega, and this point is stationary, velocity 0. Go and study this topic also. What is the velocity here, center, and here? 2 VCM, VCM 0. Very, very important topics in rotational motion. But today you can go to my playlist. Numerous questions given on rotational dynamics and kinematics. Okay, but let's come back to this. So we know the VCM is given by r omega. V is equal to r omega. Now what happens? This is a step number 1, where this is the moment of inertia of a disk about its own axis, which is this, right? About its own axis. But now what are we concentrating on? We are concentrating on the fact that the axis is lying at O. Now if you notice, the body is moving straight, right? And the center of mass is a place where the whole mass is concentrated. So the whole mass is supposed to be concentrated here, which means if I were to take the angular momentum just like a point mass, right, outside it. So we calculate one angular momentum which is about the axis which is passing through the body. We have done that. Additionally, what we need to do is add the angular momentum which is by virtue of the external axis. The axis is residing externally. Sorry, I'll just rub this off. So L, which is also because of the external axis. The sum of the angular momentum about your own axis and the angular momentum when your axis is outside the body, additional information given to you, the total gives you the total angular momentum. Okay, the total of these two. Okay, now if I were to calculate the angular momentum for the second scenario, which is outside the axis, I have done it on the center of the disk. I have already done. Now what am I doing? I am doing outside the axis. How do I do this? I know the center is here, so it has a m v R, right? And what is R here? So M, and the velocity is how much of this point? You can see the perpendicular distance from origin. I have to drop a perpendicular, right? This is my perpendicular. So M is the mass of the disk into R omega multiplied by R is equal to M omega R square. Okay. So I will add these two. Its own angular momentum about its own axis plus the angular momentum due to the axis which is passing through the origin. So the total is going to be mr squared by 2 multiplied by omega plus it is going to be how much? mr squared omega is equal to 3 by 2 m r omega. This is the actual answer. Okay, go and look at the choices. The choice number 3 is the correct choice. Don't forget to subscribe to this channel. Join the community. You will see some other students asking you some wonderful questions. Also, you will see a lot of questions coming from me. I have put around more than 1,500 questions by now. You can practice for your JEE mains, NEET examination, AP, Telangana, West Bengal, JEE. Whatever exam you give, AP Physics, IB board, Excel, CBSE board, all types of questions of all levels are available in different playlists. Go to the playlist also. So don't forget to subscribe to this channel and also spread it among your friends and in your relatives so that everybody can benefit from the physics which is explained. Okay, this is the only channel which is giving explanation so that you get a good conceptual grounding and are able to score high in the exam without much stress. The stress comes because of low clarity. As the clarity will start emerging, you will realize the stress goes down and you start enjoying physics. But you need to have that conceptual grounding, and that will come through if you go through my lectures, you go through my concept videos of 1 minute and such numericals on practice, where you also tend to gain what's happening in the world of angular momentum, for example. My last 8 videos are all about angular momentum. So I hope you like this question. Thank you very much and wait for my next video.